What is up, Pre-Cal 12? It's Coach Jay in the house. Hey, sorry I couldn't be with you today, but I do have this podcast here. Hopefully this is helpful for you as you navigate it. Good news is that if you do have any questions on Friday, you can feel free to ask me questions. We'll have some Q&A off of this. We're not going to go any further than this podcast, so check it out. Again, that doesn't mean don't check it out. Please make sure you watch it. Make sure you're up on top of it. And kind of go from there, all right? All right, very good. Let's go ahead and get started with this. The first thing today is the SAT problem. You know the tests are in. You kind of see the tests. Feel free to look at that. We'll talk about that more on Friday. But in looking at this new section, you'll notice that in the back of the room, underneath the 5 pillars, there will be notes back there for you if you decide to use that, or you could use the homeworks. Obviously, the homeworks will be there too. So feel free to get the homeworks done. The homeworks will be due on, I think I said Friday, so don't quote me on that, but check out on campus. I know that is up to date. All right, so with this, we're going to look at sequences today, this idea of creating sequences and recognizing patterns. So as we look at this, we notice that we have an A, a C, and 5 E's, so it kind of goes 1 through 5. We can recognize the fact that we're going to have 7, and the fact that it goes A blank, C blank, E blank, and we would recognize that this would actually be a G, right? So G would be down below. Notice that all of them are capitalized, so 7 G's would be kind of what we're looking for, which would be A, okay? That would be A. The second part that we're going to look into, this idea of infinite and finite sequences. As you can imagine, an infinite sequence is something that keeps going on and on for forever. Couple of things to note. A sub 1, we call it A sub 1, is what we call the first term. Okay, so anytime I say A sub 1, that is the first term. A sub n, we call the nth term. We don't know what n is, but we would say that that would be the nth term of a sequence. That's here, okay? And so that would be infinite, going to infinity and beyond. And then obviously a finite sequence would be something that has a specific endpoint. Like we have terms that have a specific endpoint that is there. Okay, cool. So let's go to this part here. This is just a fun thing. I want you to take just a couple of minutes to see if you could solve it. Tell you what, if you could solve this over by well, right now it's on my right side, but you know where the candy jar is? If you get something, go ahead and get something up there. If you could solve for all 4 lights, okay? So basically the idea is this: when you scan this here, you will see if I've got it here, perfect. You will see like this idea of 1, 2, level 1, 2, and 3, okay? So we're going to start at level 3, and what we're going to look at is what happens as we go from, you know, like whatever number that comes in. So like as I go to 1, nothing is lit up, right? So 0, yellow is lit up. 1, nothing, right? 2, yellow is lit up. 3, green is lit up. 4, green is lit up. 5, blue is lit up. And what you're going to do, maybe this will help you to kind of find the pattern. I found that it would be easier if you simply, let me actually bring this over, okay? All right, it might be easier to do this. So we would say, kind of going backwards, we'd say, all right, let's see here. All right, let's see. Exit. See if I can actually, I don't know if I can do that there. I might have to actually go through. But regardless, what I could do is just kind of go backwards and say, okay, yellow is 0 to 8, 12, 0 to 8, 12, 22, 0, 8, 2, 12, 22. So you would just put down, all right, here we go. Here would be yellow, 0, 2, 8, 12, and 22. And you would look at this and say, okay, what is the pattern that is here? Well, let's say we're adding by 2, adding by 4, adding by 6, No, that's right. No, it's 4 again. That's a tough one. But you have to find, based upon this sequence, you're going to have to find what that pattern is. I'm trying to even see for that one. Let me go backwards. Sometimes it's easier to get one and then come back to the other one. Let's go ahead. Let me try red. Here we go. Let's go red. We're looking at just when red comes up. 8, 9, 13, 16. 8, 9, 13, 16, 24. 8, 9, 13, 16, 24. 8, 9, 13, 16, and 24. And what we're trying to do is we're trying to see, based upon this is our red one, what is the pattern associated to level 3 with the red bulb? So like, what is going on? And your job is to be able to figure that out. How do I do that? And how do I get there? And all of these things. I think it's going to be a good challenge for you in finding it. If that's a little too hard, because sometimes even some of these are tough for me, start on level 1. So if you did this one, you just started on level 1. We start at 0, 1. I'm looking at the yellow one, by the way. 11, 21. So we start at 1. We just keep adding by 10 to get to what the yellow one is. So talk about the rule real quick. See if you could solve it, and if you can, go ahead and get yourself something over on that side for fun there, okay? Hey, real quick, I wanted to show you this. Real quick, this is pretty cool. I love this. This is actually really, really good. So basically, this is on YouTube. It's called The Knowing. And I'll actually turn down my music here, turn this off. This is really good. I really want you to check this out. I don't know if this is going to actually go through. Actually, I don't know if it would go through. But if you get a chance, actually do this. Go ahead and watch the trailer for The Knowing. Right now, pause this video, open up a new one, and watch the trailer. And I'm curious to see if you could see some of the cool things with the patterns and different things there. So pause me real quick, okay? Wasting time. They got a little M for you today. All right, unpause me if you are done with it. We're going to go ahead to the first section. As you saw with The Knowing, what we see was that there are patterns that happens, right? As specific numbers come up of terms in the sequence, we're able to see specific patterns, both finite and infinite. That's what's cool about sequences. Things like the matrix, or, well, The Knowing would be a good one, or any mathematician. The big thing is recognizing patterns, recognizing sequences. And really that's what we're going to do today. All right, so remember, as we look at this, we're going to write the first 5 terms of these sequences. We can use a table feature of our graphing calculator to be able to verify this. But remember that when we look at like 6, where a sub n is our what it's equal to, a sub n is saying what is the nth term? What is the nth term? Okay. Now the question is writing the first terms where n begins with 1, we go ahead and find what a sub 1 is by simply plugging 1 in for n. So that would be like -2 to the first. A sub 2 would be -2 to the second. A sub 3 would be -2 to the third. A sub 4 would be -2 to the fourth. And a sub 5 would be -2 to the fifth, okay? And so looking at this, the first 5 terms of this would be equal to -2, 4, -2 to the third is -8, -2 to the fourth is 16, and -2 to the fifth is -32. And so that would be our sequence, our 5 terms, our first 5 terms of our sequence. You could do the same for number 7. So a sub 1 equals 1 plus 1 divided by 1. We know that to be 2. But there's actually an easier way to do this. And I'm going to actually, I'll do a more complicated one down on number 12, where you could actually plug this in your calculator. It's kind of nice. So think of this as like, okay, this is y equals. We're looking at number 12. Putting in the top, we want to make sure we funnel that in. So we'd say 1 plus -1 to the x power. And then divide that whole thing. Make sure you use parentheses. That's the big thing. Divided by 2, 2x. Cool? All right, so once I put that here as y1, here's our equation. We can go to second graph, which is our table feature. And what we have here is we get this idea of a, let me go down here. As we plug certain values in for x, we get certain values out for y, which is really our a sub n. So we should start at 0. And if I plugged in 0, I'm trying to see, how did that not do that? How did that do that? That's incorrect there. I don't know why this one's not working. Let me do a more basic one. I don't know why that's coming up like that. Second graph, let me make sure going down. Plug 1 in. I don't know why it's saying error. That's weird. Okay, let me try another one. Let me go to y equals. It could be something in my calculator. So don't worry. Let's go to the this one over here, n plus 1. We'll just do x plus 1. X plus 1. And then divide that by x. So we'll go to second table. And as we plug in, we notice, yeah, this is better. Plugging in 1, we get 2, right? Don't ignore the decimals. In fact, you could go to second window and make the table start at 0 and make every time it kind of add by 1. So when I do this, I'll go, the answers would be 2, 1.5, 1.33, 1.25, and 1.2. So the fifth term, meaning a sub 5, would be 1.2. And that might be a good way to just kind of check it and plug it in as you're going through this first part that is here. Okay. Next part, 31, is another good example of one where we want to plug it into our calculator. If we were to look at 32, it says use the table feature. So as we plug things in, sorry, I don't know who that was. That was crazy. We're going to plug this in as 2x times x plus 1 times x plus 2. And then again, we'll go to second graph. We'll go to our table. So when we plug in 1, we get 12. Plug in 2 for our second term, we get 48, 120, 240, and 420. And so those are some ways that we could plug in our calculator to get the specific terms of our sequence. Really, it should be going from 1 all the way to 10. Be careful. Make sure it says when it says n begins with 1, make sure you know that, you identify with that before going forward. All right, now here's the toughest part of this lesson. Okay, toughest part. We're going to go into some practice, and then we're going to have you kind of do some as well on your notes, and just to kind of help with it. A couple of them are on your homework as well, so you could match some of the ones up that are here. All right, so here's the idea. In this example, we're trying to look for the sequence, similar to what we were doing with the Charlie's Delightful Machine. We're trying to look for what the sequence is of each of these numbers that are here. So like in looking at number 4, we have a pretty easy one here where basically we say, we start with 3, and then we continue to add by 4, right? You see it? Plus 4, plus 4, plus 4. So the equation of a sub n, we start with 3, and we add 4. But here's the thing, you can't just say plus 4. You have to say, all right, well, what are we adding 4 to? Well, we're going to say 3 plus 4, n. Okay? Now, the key is once I kind of get what the term is, I have to double check it. Okay? I have to really double check it. So what can I plug in to n? Well, if I plug it in for n, if I plug 1 in, I get 3 plus 4, which is 7. The second term would be 8 plus 3 is 11. You see what we're doing? 15. Keep adding. 19. But we're 1 back. We're kind of back from this. So we need to subtract this thing by 4. Follow me? Because you say, Coach, why is that? Well, I need to subtract by 4 on each of these to get to where this is 3, 7, 11, 15. It's now at the correct spot. So I've got to subtract this equation by 4, which just means that I'm going to get a sub n equals negative 1 plus 4n. And that would be our answer. Okay? Again, you could check it, plug 1 in, plug 2 in, plug 3 in, plug 4 in, 5 in, and you should get that specific sequence that's up on top. All right, the next one, we notice that 1, if you see a fraction, we have 2 things going on. We have the top, and then we have the bottom. So we have 2 specific they're differences, okay? So on the second one, we have a sub n equals, the 1 stays the same on the top, so we have no variable up there. The bottom one, though, goes from 1, 4, 9, 16, 25. Well, you could kind of see that this is just taking a value and squaring it, right? So 1, 4, 9, 16, 25. So if I went n squared, I could check this by putting 1 in for n. So a sub 1 is 1 over n squared, which is 1 over 1, which is 1. A sub 2 is 1 over 2 squared, which is 1 over 4. A sub 3, 1 over 9. A sub 4, 1 over 16, and so on and so forth, okay? That would be number 42. Number 45, similar, kind of a little similar to this, except the top has 1, negative 1, 1, negative 1, okay? All right, so kind of a little bit weird. So I would say this, a couple things on the side here. Let's make a little chart here. So there's a couple things, kind of strategies. If I see 1, 4, 9, 16, 25, yeah, we're thinking n squared, right? Thinking n squared, at least starting it. If I go, if I am going 3, 7, 11, 15, we're adding by 4, but to put that in an equation form, that would actually be 4n, right? Because every time I put one number in, it's multiplying by 4, which really is the same as adding in terms of the sequence when you check it. Now, when I go from 1, negative 1, 1, negative 1, a hint on this is taking negative 1 to the n power, okay? Say, Coach, what does that do? Well, look at the top. So let's say I have here a sub n equals, and let's say I say negative 1 to the n power. Just looking at the top, if I put 1 in for that, I get negative 1. If I put 2 in for that, I get positive 1. 3 would be negative, positive, negative, and there we go. But here it's positive, negative, right? So when I go back and forth between that, we would say that negative 1 to the n would not be really true because we're off a little bit. So we're just going to put to the n plus 1 based upon how they go, right? So they start with positive, then go negative. Then on this next part, they have 2, 4, 8, 16, which really, what are we doing? We're multiplying by 2 each time, which gets me to my next thing. When I go 2, 4, 6, and 8, you're not going to do 2n. You're going to say 2 to the n power, okay? So look right down below. So if I did 2 to the n power, let's check just the bottom. Plug 1 in, we get 2. Plug 2 in, we get 4. 3 in, we get 8. 4, we get 16. And so this right here would be that sequence there, okay? That sequence. Man, I hope this is, you're kind of getting this. This kind of can get a little bit tricky, let's go on to the next part here. Hopefully you got those 4 things on top down. The bottom, let's talk about the bottom here first. This is being multiplied by 3 each time. So because this is being multiplied by 3, similar to the other one, we're going to say this is 3 to the n power. On the top, we see that it's 1, negative 2, 4, negative 8. And so what's happening here is this is being multiplied by 2 each time, again. But because of the change in sign, positive, negative, we can simply look at this and say, okay, this would be, looks like 2 to the n power. But when I plug 1 in, I get 2, and when I plug 2 in, I get 4, and then 8, and then 16. But notice this is off just a little bit. It's actually got to go back 1. So what we're going to do here is we're going to step back 1, going to go to the left 1 by subtracting by 1. You say, Coach, what does that do? Well, 2 to the 1 minus 1 would be 1. 2 to the 2 would be, well, 2 minus 1 is 2 to the first, which is 2. And this actually gives me the correct part. Now, positive, negative might be a little tricky. So now I've got to kind of figure out what I can do here on this. Well, we know that this would be 2 times, or 2 to the n minus 1. And then in order to kind of fill it in a little bit, to be able to get the positive, negative, remember, how did we do that up here? Well, that was actually put in. I'm just making sure if I can put in. I think I could just put a negative here. So negative 2 to the 0 is 1. Negative 2 to the, so I might have to put this in parentheses so that negative 2 is to something. But yeah, that would be our response here to get from positive, negative, okay? Cool. All right, I hope this is somewhat making sense. This is going to take a little bit. So Friday, we're going to really look through this, okay? All right, they kind of helped you here. This would be a little different here where you have 1, 2, 3, 4, and 5 being multiplied. If you look at it, this would be multiplied by 1, multiplied by 2, multiplied by 3, multiplied by 4, and then multiplied by 5 to get to the next one, right? Whereas the top would be like 2 to the 0, 2 to the first, 2 to the second, 2 to the third. And you say, why is it 2 to the 0? Well, 2 to the 0 is 1, right? So what we could do here is just say, okay, we'll start by saying 2 to the n, even though we know we're going to be 1 off, right? So we got to go back 1 to the left 1, so we're going to say 2 to the n minus 1, okay? That's the top. Now on the bottom, when I do 1 times 1, 2, 3, 4, 5, think of n factorial, which just means that if I have 3 factorial, that would be 3 times 2, which is equal to 6. Or if I have 4 factorial, that would be 4 times 3 times 2 times 1, right? Or, yeah, this should have 1, but 1 is nothing. So that would be 24, right? And what happens is it keeps multiplying by one thing that's greater as you move forward. So if I did n factorial here, n factorial would be 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. And you'll notice the pattern that's there. But again, we have to go back 1. We have to go back 1 because we need that extra 1 there, which I know is weird that actually 0 factorial is still 1. That's kind of a side note. But if I did n minus 1, I went back 1 and did the factorial, that would get me the bottom part that is there. That is a lot of information. That is a really tough concept. And we're going to keep hitting on this as we go. It kind of progresses as you go down. Go ahead and try some of these both on your homework and with what's behind. Pause the video. See if you can get some right, okay? Cool beans. All right. Hey, as we go to this next topic, this is called recursive. It's not as difficult as the next one, or as the last one. I thought the last one's one of the tougher topics on this unit that's here. But recursive is just this idea of constantly being plugged back in. So if you were to look at a sub 1 equals 6, it's a fancy way of saying if I plug 6 in for a sub k, okay? So we're going to do that. We're going to plug 1 in for k, 6 in for a sub k. We would say that this would be a sub 1 plus 1 is equal to 6 plus 2, okay? All right, so what are we saying with this? Well, we know a sub 1 is 6, but we would say that a sub 2, right here, 2, would be equal to 8. And you say, Coach, what would I do to get a sub 3? Well, I would plug 8 back in for a sub k. 3 plus 1 is 4. I'm sorry, 2 plus, sorry, because I'm plugging 2 in. 2 plus 1 is 3, a sub 3, is equal to 8 plus 2, which is 10. You'll see a pattern, a sub 4. I'll plug 3 back in for k, and 10 back in for a sub k, and we get 12. A sub 5, we plug 12 back in for a sub k here, and 4 back in for k, so a sub 5 would be equal to 14. So the 5 terms that we would use here are the 4 ones you see on this as well, okay? Now in finding the nth term of this, similar, we're adding by 2 each time, and what do we do when we add by 2? We know that we're going to add 2n to it. It's just something that we know of when we come to a sub n. And so when we put a sub n in, where do we begin we know we start with 6, right? So if I put 6 plus 2n in, and I put, okay, I want the first term, I plug 1 in, I'm going to be off a little bit, right? If you notice that, I'm going to be off, because 6 plus 2 would be 8, so I would be here instead of here. So I want to be here, so I want to subtract 2 to get to 6. So when I subtract 2 by this equation, the equation we would get would be 4 plus 2n to get the 5 terms that are there, okay? All right, look at 59. Again, we'll do this one together. 59, a sub 1 is 81. We plug 81 in for a sub k. 81 divided by 3 is 27. Put 27 back in for a sub k. All right, so literally it would be, just so I could show you again, a sub 2 plus 1 equals 1/3 times 27. So that would be 9. So a sub 3 would be 9. And a sub 4 would be 3. A sub 5 would be 1. And then what happens is what's occurring is we're multiplying by 1/3 each time here, okay? Well, again, what are we doing? Well, if I'm taking 81, right, and I'm multiplying by 1/3 each time, it's really 1/3 to the n power that is being multiplied, and we start with 81. So if I did that, I said, okay, a sub n is equal to 81 times 1/3 to the n. Well, if I plug one in, I get 27, but I need to go backwards, right? So I need to multiply, or I need to change this n to where it goes back 1, and that's where I put n minus 1 in this spot here, okay? Cool. There are multiple ways that you could find these equations, but recursive just means that what I plug in for the first gets plugged in and recycled to the second, third, fourth, and fifth term, okay? All right, hey, these ones right here are another thing when we talk about factorial here. When we refer to that, it's really addressing this idea of multiplying out, right? So if I did 62 of 1 over n plus 1 factorial, I want to make sure I could kind of do one of these when I look at the first 5 terms. I would say in here, n begins with 0, to make sure you check that. So that would be a sub 0 equals 1 over 0 plus 1 factorial. So again, 1 factorial is 1, 1 over 1 is 1. Second term, put 1 in. We're just going to go in order. I know it's weird because it's 1, but we'll go in order. 1 over 1 plus 1 factorial. 2 factorial would be 1 over 2 times 1, which is 1/2. The second one is 1 over 2 plus 1 factorial, which is equal to 1 over 3 times 2 times 1, which would be 1/6. Okay? The third one, 1 over 3 plus 1, which is 1 over 4 times 3 times 2 times 1, which is 1 over 24. And there's one more, which is a sub 4, which is, as you can see, you kind of see the pattern of this. 5, 4, 3, 2, and 1, which is 1 over 120, I believe. Okay? So as I look at this, these are the ways that we could find it. You could also put it in as a decimal. Another way you could write this is actually going to your calculator again. I'll kind of show you. So you could plug in, let's say, n factorial. So I'm going to put this in. So x factorial, I believe, let's see, I think there is, right here. You can go to the probability. So math probability, x factorial, and then divided by 2x plus 1. And there we are. Okay? And then once we do this, we could go to second graph, and there we are. We'll start at 0. Here are our 5 answers, and we go from, because it says start at 0, first term, second term, third term, fourth term, fifth term. We just write what those solutions are going downward there. Okay? All right, the last thing that I wanted to look at real quick, and we'll look at the summation stuff later on. If you remind me on Friday, we'll look at that as well. Look at 69, where we have 12 factorial over 4 factorial times 8 factorial. This is not bad. 12 factorial would mean 12 times 11 times 10 times 9 times 8 times 7. We could keep going, right? Dot, dot, dot. Over here, 4 would be 4 times 3 times 2 times 1. 8 would be 8 times 7 times 6 times 5, dot, 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 right? All the way through. Now, as we look at this, we could cancel some of these things out here. If I look at 8, 7, 6, 5, 4, 3, 2, right there we cancel out. We cancel out on that side. And then once we look at it, we look what's left over. So like 4 times 3 would be 12, so I could actually take a 12 out on top and bottom. 2 can actually go into 10 5 times. And so what's left over is 11 times 5 times 9. That's here. And it may be easier than to do an X to just do the dot, 11 times 5 times 9. So 45 times 11, that would be 5 and 4, 450 here. And I think that'd be 495. It should be 495 would be my answer. But the idea is that it keeps subtracting. If you look at, like, for instance, n plus 2, exclamation, even though it doesn't have a number, we're going to keep subtracting by 1. So n plus 2, n plus 1, n minus 1, and dot, dot, dot. On the bottom, this would be n times n minus 1 times n minus 2, and dot, dot, dot. So anything that is n minus 1, n, anything to the right side of it, because it's dot, 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 we take out. And my answer would be n plus 2 times n plus 1. It's just a good example of what we're doing within our factorials that are there, okay? I might give you one more partial sum just to kind of let you know how to do this real quick. I'll do a basic one for you, and then I'll have you do it. This thing right here is not just a cool tattoo, okay? Don't get a tattoo, okay? Or I'll do this one. That's probably easier. It's not just a cool summation, but it's actually something that we can plug values into. So if I plug 1 in for I, we start with the number on the bottom and we progress towards the top. So if I plug 1 in, that'd be 3 times 1 is 3 minus 1 is 2. For the second term, we would get plug 2 in. 2 times 3 is 6 minus 1 is 5. For 3, we plug 3 in for I. 3 times 3 is 9 minus 1 is 8. And you'll see you keep adding by 3 on this one to get 11, 14. So you go 1, 1, 2, 3, 4, 5. We'll do one more time to get 17. But the summation symbol means that we sum up all of the numbers in my sequence. So I add them all up, I add them all up, add them all up to get 31, 19. I'm just simplifying. This would be 26 plus 31 is 57. So the summation would be 57 there. Hey, I've got a class coming. Hope that was helpful for you. Love y'all, and hope this podcast was helpful. See ya. Bye.